Quick riddle. One AI model has 671 billion parameters. Another has 70. The big one answers faster, and it costs less per word. That's not a typo. It's the single biggest reason the models you used this year got bigger and cheaper at the same time. The trick has a name: mixture of experts. So how does a model use less of itself and somehow get smarter? Let's open it up. Okay, so here's how a normal model works. We call it a dense model. Every time it reads a single word, every parameter fires. All of them. Ask it the capital of France, and the parts that only know Python or organic chemistry light up too. It's like emailing one quick question and waking up the entire company to answer it. The answer's fine, but you just paid for everyone's time, and with a dense model, you pay that bill for the whole brain on every single word. Mixture of experts fixes this with one idea. Take that giant layer of neurons and chop it into a bunch of smaller groups. Each group is an expert, basically a specialist. Then you add a tiny traffic cop called a router. For each word, the router looks at it and picks just the best one or two experts to handle it. Everyone else stays asleep. So instead of waking the whole company, you call the two people who actually know the answer. Same building, same knowledge, a fraction of the work. But who decided that this expert knows code and that one knows poetry? Nobody did. Every expert starts out identical. As the model trains, it just nudges itself to do a little better step by step. Gradient descent. And the experts drift apart and specialize entirely on their own. But here's the twist. When researchers cracked open a real model, the experts hadn't split by topic at all. No math expert, no biology expert. They latched onto tiny patterns, punctuation, indentation, the shape of the text. And there's a trap. Left alone, the router plays favorites. A few experts get all the work, get better, and get picked even more, while the rest just die. So training adds a load balancing loss, a penalty for playing favorites, and keeps every expert in the game. This gives you one rule that explains everything. Your total parameters are how much the model knows. The active ones, the experts who actually wake up, are what you pay for. Knowledge and cost, finally unhooked from each other. Take Mixtral. It holds 47 billion parameters, but only runs 2 experts at a time. So it answers at the speed of a model a quarter its size. DeepSeek goes further, 256 experts on the shelf, and it picks 8. Huge brain, tiny bill. But wait, this isn't totally free. Even though only 2 experts run, all of them still have to sit in the chip's memory, ready to go. So you need room for the whole crowd, even the ones napping. A bigger brain, with more experts, still needs a bigger pool of memory to hold it. But what you pay to actually run it barely moves. How much a model knows is finally unchained from what it costs to run. And this is the payoff you actually felt. It's why, in 2026, the price of using LLMs fell off a cliff. On NVIDIA's newest chips, a mixture of experts model like DeepSeek runs about 10 times faster for roughly 1/10 the cost per word compared to the generation before it. Trillion parameter intelligence at chatbot prices. And it's not just the cloud. Since each word only wakes a couple of experts, you don't need a data center GPU to get a real answer. The sleeping experts can wait in ordinary memory, so a genuinely capable model can run on your own laptop. That's the whole trick. The model just stopped doing all its thinking with its whole brain. So next time a model feels impossibly fast for its size, it's probably not thinking with its whole brain. It's calling the right experts. And nearly every frontier model you touch this year works exactly like that.